Hello class, today we are learning what parent functions are and how to identify them. So your essential question is, how do I identify parent functions? Your learning intention. I am learning to identify functions and parent functions. So you've got two warm-up questions. One is a graph, and you're going to decide if it's a function or not. And the second one is a function, and you're going to evaluate it. So please pause the video and do the two warm-up questions now. Well, I hope you try it on your own. If we're looking at this, all we have to do is draw that vertical line. A graph of a function will pass the vertical line test. This one does not. So my explanation as to why, not a function, because it does not pass the vertical line test. Okay, hopefully you got that correct. To be a function, each input must go to exactly one output. So, in this case, it goes to the same output here and here. The same number goes to different outputs there. So it cannot be a function. To evaluate means I am going to replace. So this is my function. This tells me what x is equal to. Now let's substitute. So when I take the function g and I put in -5 for x, I take 2 times -5 quantity squared minus 7. When I've got my function g and I evaluate it with -5, 2 times -5 times -5 is 25 minus 7. So next step, when I take my function g and I put in -5, I have 50 minus 7, which gives me 43. So this number is 43. I use my function g. I put in -5 for x, and I got out 43 as my output. So the functions that we're going to look at on the front and back of this set of notes are the ones you have to know. I will also introduce you to some I want you to know. So here we go. Linear. If I'm looking at the first parent function, it's a linear. Remember when we did that y equals mx plus b? That was a linear function. Okay, so if it is linear, we know the graph will be a what? Right in the name. It will be a line. Linear tells us line, we expect a line. So if I'm looking at the function g, when I put in x, I get x back out. So whatever x is, that is also going to be my output. So if I put in -1, I get out -1. If I put in 0, I get out 0. If I put in 1, I get out 1, and so forth. This one actually should be 3. Sorry. I'll have to go in and correct that on my notes. Okay, so what does it look like when we actually do graph this? This is your first point, -1, -1. Go over and go down. 0, 0, 1, 1, 2, 2, 3, 3. As you can see, this line kind of cuts my Cartesian plane right through the middle. So the graph is a line. And remember, lines go on forever and ever. Think of Buzz Lightyear. To infinity and beyond. So, your exponent is 1. So it's going to be to that first power. We normally don't put the first power in, but it is understood to be there. Okay, quadratic. We are squaring the number. So if I'm looking at the first one, I'm taking -3 times -3. That's what squaring a number means. I take the number times itself. Negative times negative is a positive, so this would be 9. -2 times -2. Negative times negative is a positive. 2 times 2 is 4. 0 times anything is 0. 2 times 2 is 4. 3 times 3 is 9. As you can see, it gets really big, really fast. -3, 9. -2, 4. -1, 1. 0, 0. Now, the neat part of it is symmetric. You see the same outputs again. 1, 1, 2, 4, and 3, 9. So when I draw this graph, it kind of looks like a parabola. So the shape is a parabola. And it can be like this, or it can be opening down. So you will see it looking like this, or you might see it flipped upside down. Your exponent is 2. So when you see anything squared, you're going to get that parabola shape. Depending on if you've got the coefficient of x squared as positive or negative, it will either open up or open down. I was really proud of the class that was able to answer, what is an absolute value? They told me it is the distance from 0. So I hope you can remember that. How far is -3 from 0? Well, it's 3 units from 0. How far is -1 from 0? It is 1 unit from 0. 0 is in the middle. This is 1 unit away and 3 units away. Basically, your absolute value will remove the sign. So what does it look like? Once again, it is symmetric about the y-axis. And if you notice, it comes down and goes straight back up. It is a V shape. It could be an upside down V shape. Both of them will work depending on your coefficient being positive or negative. In this case, there is no exponent. It is what it is. Okay, so for the cubic function, cubic means to the third power. So this will be -2 times -2 times -2. -2 times -2 is 4. 4 times -2 is -8. -1 times -1 times -1. Negative times negative is a positive. Positive times negative is a negative. 1 times 1 times 1 is 1. So this is -1. 0 multiplied by itself 3 times is 0. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 again is 8. So the numbers repeat only. You go from negative to positive. So this kind of looks like an elongated S. If I'm looking at this, here's 0, 0, 1, -1, and then 2 is clear down here at 8. 1, 1, 2 is clear up here at 8. So it's kind of like an elongated sideways S. That's what it looks like. Your exponent is 3. So you need to know what a linear function looks like, what a quadratic function looks like, what an absolute value function looks like, and what a cubic function looks like. You know you're successful when you can identify these parent functions. Parent functions, linear, quadratic, absolute value, and cubic. Okay, you have a handout to work on. It also contains the the graph of the square root function. So when you do the first side, you've got everything pretty much there to copy from. But on your square root function, I want you to be aware of this. The square root of 0. What number times itself gives me 0? Well, that would be 0. What number times itself gives me 4? That would be 2. What number times itself gives me 9? That will be 3. So you can see this doesn't go up very fast at all. So you start at 0, 0. Then you go over to 2. Go over to 4. 1, 2, 3, 4. You go up 2. You go over to 9 and you go up 3. So it looks like half of the quadratic. It looks like it's half of that quadratic. But that kind of makes sense when you realize that squaring, which is your quadratic function, and square rooting, which undoes squaring, are opposite functions.